This, we will understand about how do we find the confidence interval for a population mean if the sample size is large and the population standard deviation is known. The interval estimate of a population mean when the sample size is large with the confidence coefficient 1 minus alpha. Here alpha is nothing but significance level, what we had seen in our testing of hypothesis. Here confidence level is opposite to your significance level. For example, if it is 5% level of significance, then confidence level will become 95%. If it is 1%, then confidence coefficient will become 0.99. So sigma is known, is given by x bar plus or minus z sigma divided by square root of n, where this x bar is your sample mean, z is the table value for a standard normal distribution for a two-tailed test for the given confidence level. For example, as we discussed already, if it is a 95% confidence level, then we will look in for 5% significance level. Two-tailed value is what? Sigma is the population standard deviation and n is your sample size. Now, to understand this, we'll go with one numerical problem. The average monthly electricity consumption for a sample of 100 families. Since sample size is given as 100, we will say n is 100 and the sample average is 1250. So x bar is 1250. Then assuming the standard deviation of electric consumption of all the families is 150 units, which means our sigma value is 150. We need to construct a 95% confidence interval for this. So the confidence interval will be x bar. We already saw that how to find x bar z sigma divided by root n, z plus or minus z sigma divided by square root of n, which will become now 1250 plus or minus z value for 95% confidence for a two-tailed will become now 1.96. So we will substitute 1.96 for the z. Sigma is given in the question as 150 and root of 100. Now, if we evaluate this, we will get 1250 plus or minus 29.4. That is, the confidence interval will be, first one will be the subtraction of these two. If I subtract these two, we will get 1220.6 as the lower limit. Upper limit will be 1279.4. I am putting a box bracket, which means that it is inclusive of these two numbers, which means that our mu value, that is population mean, will lie between these two numbers. Let us go with another problem. In order to introduce some incentive for higher balance in savings accounts, a random sample of size 64 savings accounts at a bank's branch was studied to estimate the average monthly balance in savings bank accounts. Means you are trying to find out where the population mean will lie, that is average monthly balance will lie when the sample size is 64. Sample size here it is large. Mean and standard deviation were found to be 8,500 and 2,000 respectively. Then we need to find the confidence interval for difference confidence intervals for difference level. One is 90%, 95%, 99%. Let us solve it in the next slide. First of all, n is given as 64 sample size. And then the mean and the standard deviation is given to be 8,500 and 2,000 respectively. Means sample mean is given as 8,500 and standard deviation is given as 2,000. So the confidence interval will be x bar plus or minus z sigma divided by root n. First one, if 90% confidence level, then the corresponding Z value will be means 10% significance level for a two-tailed test, it will be 1.645. So our confidence interval will be X bar, that is 8,500 plus or minus 1.645 times sigma, which is 2000 divided by square root of 64. If we evaluate this, we will get 8500 plus or minus 411.25. So that means our confidence interval will be lower limit. We'll see what it is. $8,500 minus 411.25. We get 8088.75. Upper limit, we will be adding 8911.25. Means the population mean will lie between these two values. Next, for a 95% confidence, we already saw that in the previous problem, Z value will be 1.96. So therefore, our confidence interval will be 8,500 plus or minus 1.96 times 2000 divided by square root of 64. If we evaluate that, we will get 8,500 plus or minus 490, which means our lower limit will be 8010 and the upper limit will be 8990. Then third, for 99% confidence, Z value will be, it is basically 1% level of significance. We will get 2.58. Confidence interval will be 8500 plus or minus 2.58 into 2000 divided by root 64 is 8. So if we evaluate that, we will get 8 into 2000 divided by 8. We get plus or minus 645, which means our confidence interval will be lower limit is 7855. Upper limit will be 9145. We may also notice one more thing. Once the confidence percentage is getting increased, even the interval is also getting enlarged. So here it is 8088 to 8911 for 90%. For 95%, it is further getting enlarged. 8010 to 8990 and 99 further it is getting expanded. The limits are getting expanded. So this is the solution for this fourth question.